think yes. Okay. Let's start. Yes, let me share my screen. But before I started, I see that we have mirrored images, right, on the side. Yes, but we have a problem about mirror the picture, mirror the presentation. Can we fix it?
We can see it. It's not mirrored for us. It's, oh, wait, I get what you're saying. So it's being mirrored in the screen. Yeah.
Yes, absolutely.
I think I can fix that. Just a moment. How about now? Is that okay?
For me, no, it's still mirrored. But guys on YouTube tell me that it's good on their side.
Okay.
Oh.
Infinite loop. All right. Thank you, Irina.
Okay. Should I start, guys? Okay, let's start. So let me do this, my presentation. Here we go. Today we will discuss LLM, of course, and to be more specific, local LLM and LLM security. And let's get acquainted. My name is Irina, and I'm a head of the machine learning R&D department at RAV Digital Solution. I have experience in deploying various machine learning models, from time series analysis and computer vision to high-load data engineering services. Yep. So let me take off my camera. And let's go to dive to my presentation. So guys, it's our plan of today. First of all, it will be a quick overview of current state of machine learning, or why we are still far from AGI. Our second step is local versus API-based LLM. Our next step is a deep dive into LLM attacks methods. And next step is my favorite step. I really like these topics. It's a fine-tuning dark horse of attack. And last but not least, of course, the AI armor. This we will discuss how to protect your LLM solution from attack and techniques how you can protect your solution. So I hope I managed to interest you. Let's go. When we talk about artificial intelligence, we essentially discuss the art and science of process modeling. AI is not a just futuristic concept, and of course you know it, and it's a sophisticated discipline that mirrors our really long-standing traditional of studying and simulating various processes. Whenever it's cognitive functions or random events or natural phenomena or industrial operations, for example, humans have always thought to understand and replicate this process. I think that's why we have a classic ML model and neural networks now, don't you? For example, as you can see in computer vision, we model human vision, striving to endow machines with the ability to perceive and interpret visual information. Similarly, in natural language processing, NLP, we aim to emulate the human capability to generate and analyze language. That's okay. So, If we look the current state of LLMs, we will see that they are not a black box, but rather a programmed neural network involving step by step with advancement of technological progress. So on this picture, we will move from the bottom up, and we have a HMM or CRF. It's a step, so old step when we get a grammar in short phrases without errors. I mean, we can predict only phrases and sentence. After that was a word embedding space. Yes, and on this stage we can understand the meaning of words. That was great. After that was step about recurrent neural network and LSTM neural network along short-term memory that have us ability the meaning of words in context. It was first step to RLHF and LLM, I thought. After that, of course, you know this step is transformers after regressive LLMs. And these models, of course, attention is all you need. These models give us opportunity, give us ability, the meaning of the whole text. It was about syntax. Yes, syntax stage. And after that, it's a LLM stage now. People add RLHF. It's a reinforcement learning with human feedback. And this step brought us to there we now, yes. And this idea is really simple. We add human feedback to the model's responses and train it with new information. And RLHF has made a breakthrough, allowing transformers to understand context in a way that were not possible before. But you tell me, if RLHF and LLMs are so advanced, and many people predict that AGI is imminent, what went wrong now? So why are we still far from AGI? Let's find out. Maybe you heard about it. Alice in Wonderland. It's a new benchmark for LLM, and it contains only one simple question about Alice in Wonderland. Alice has some brothers, and she also has some sisters. So, how many sisters does Alice's brother have? Yes, and people can get answer for this question really fast and really clearly, but not LLMs. And let's take a look how LLMs can beat this question. By the way, we have other LLMs benchmark, really complicated, really hard. One of them is MMLU, and you can see on the picture MMLU as a y-axis and Alice in Wonderland in x-axis. And wait a minute, I should do this. Oh no. Wait a minute, guys. I have a technical problem, I thought. So now, is it correct picture, right? Is it correct picture and my sound correct? Yes? Okay, good. So let's continue. So we have our MMLU part and our Alice in Wonderland part. And you can see that only one LLM, only one model in this benchmark is GPT-4o, but the maximum of this benchmark is 1.0,
and GPT-4o can be only 0.7. That's really sad, but you can see the other set of all our local API-based ML model, LLM model, and these models can't beat this simple benchmark. So go to previous slide. Maybe you know this guy. It's Jan LeCun. Is a father of neural network, and there is his tweet about this benchmark. And I really absolutely agree with him because yet another opportunity to point out that reasoning ability and common sense should not be confused with the ability to store and approximately retrieve many facts. That's really that's really true. And in a nutshell, just look at this. The data throughput of visual perception is approximately 16 million times higher than that of writer or spoken language data. And in just 4 years, a child has seen 50 times more data than the largest LLMs trained on all the text available on the internet. So we have some conclusions about LLMs and about attention in LLMs and about AGI, of course. Text is very redundant. That's true, and visual signals in the optic nerves are even more redundant. That redundancy is exactly what we need for self-supervised learning to capture data structures. That's great. But most human knowledge comes from our sensory experience in the physical world, and language is only icing on the cake, and we need the cake to support the icing. I think you get it. And AI will never reach human level performance without training on high throughput sensory inputs such as vision, for example. So I thought it was my answer about why we're still far from AGI. Let's go next. Local versus API-based model. Open and closed model have a different benefits, of course, and should be considered for each use case. And I don't want to say that open source is the best. Let's go with open source or API based solution is always good. No, consider it for each use case. And let's take a look for, I think, first 3 points. Open source, of course, about security models or open source models can be self-hosted. You don't send outside your data to vendor, and data stays in your environment. That's the point why the more company now, the big company to choose open source LLM. After that, after point, it's a control. Determining nature of updates and are controlled by you for open source. And it's really good because if you have your local model, you can fine tune it. You can control all checkpoints and points that you have. You can distribute your parameters, and that's great. In API-based models, we cannot self-host it like the main API-based LLM now. It's GPT, of course, and you know that it's sent outside your data, and that's okay, but not with personal data, for example, not with my really, I don't know, interesting data. So about control, yes, an API-based solution, we can control parameters too, but not so much as in open source. So let's go to the next slides. I will discuss this information in a nutshell. And we have benefits on-prem LLM, of course, flexible learning and fine-tuning, of course, batching and model throughput adjustment, scaling cost. Yeah, that's one more point for business, data and process security, and about control parameters, I think I mean latency and other parameter control. It was benefit on on-prem LLM. Benefits API LLM, there is time to market. It's a metric that means times between the idea go to your head and your proof of concept solution. Time to market really works well with API based LLM, but um, I have some soft for local LLMs that helps me to proof to make proof of concept for my idea as fast as I use GPT. So, ease of use and integration. Other point in positive side API based. Access to closed models. Yes, of course, we still don't have, maybe never have ChatGPT or any OpenAI projects in open source. But I think you can heard about the Google drop their model to open source. That's really interesting. And the last point, it's a pre-config infrastructure. That also means about time to market. If you don't have more time, if you don't have your private data, go to API LLM. If you have your private data, if you have time, so you can go to on-prem LLM and have more fun. But of course, a local LLM have issues too, and it's hallucinations, inaccurate information, robustness and stochasticity. It's when model gives you a different answer to the same query, and the most interesting point, it's a new prompt for each model. Maybe you know that in a local model world we have several models that really good. I thought it's Llama 3, Llama 3.1. It can be Qwen 2, it can be Mistral, and for all of this model, we should change our prompt. So you can't take your prompt from GPT, control where, insert it to local models, and you can't accept, you can't um, you can't take this prompt without any changes to get the great result. And ChatGPT and GPT-4, GPT-4 all project of for OpenAI, it's give us really great accuracy now. And local model from box, vanilla local model without fine tuning, not exactly ready to use without fine tuning, without training, because their accuracy now it's on level GPT 3.5. Yes, but not the last version of GPT. So the last point of local LM issues, it's a non-strict output format. And for example, we should fine-tune our model to JSON format, but GPT already have it. All of these points to follow us to the next thought, no confidence in the quality of responses. And we have some techniques to increase it. For example, fine tuning. Yes, I love fine tuning so much. For example, retrieval augmentation, it helps too. For example, vector databases, it helps too. But today we will not discuss it. So, how to evaluate the prospect of using LLM in your solution? It's short block schema about um, how you can decide. do you want or do you want to use LLM in your solution? Is it important that the result? If it's important, do you have the expertise to verify the reliability of the results? It's really important step because if you don't have, it will not really a great solution. But if you have and um, you take full responsibility for possible emissions, okay, you can use LLM. So let's go to the next part. It's a deep dive into LLM attacks methods. Uh, let's go and have a fun. So now we have key barriers to generative AI adoption, and you can see that second of them, data privacy concerns. So data privacy is one of key barriers to adopt generative AI in your solution. But why? Let's go to examples. But before, of course, we have AI security frameworks. One of them it's a OWASP Top 10 LLM, and first version have some minuses, but the second version it's a prompt injection. It can be data leaks, DOS attack, model theft, data poisoning, integration risk, or email infrastructure risk. Today we will discuss only three of them. Uh, First of all, about prompt injections. We have a classic attack, the grandma jailbreak. I think that you have heard about it. So this attack due to prompt, and we can ask LLM, ask GPT, like how to make some, I don't know, some bad things, and in the right way, GPT reject your
Irina, may I interrupt you?
yes, yes.
Because something happened, and I think it's on a Telegram level.
Oh
I
no,
don't know if you changed anything. So
no. But what moment? What moment?
uh, just when you started to explain the next slide, I think.
The grandma jailbreak? Hmm,
Uh,
probably
Probably
not.
if you interrupt your sharing and restarting again,
Yes, I
yeah,
already did it.
we return to normal. And please make it full screen.
Course. Okay, but tell me,
Okay,
please, this slide.
thank you.
What is the slide that you saw? The last slide. This one or this?
Sorry, what was the question?
What was the last slide that you saw?
Guys, which one? This one? This one. Confirmed.
Great. Yes, and after that, I tell about key security issue today. Key security issue in general in LLM's world. First of all, it's a prompt injection. Second one is a data leaks. Third one, DDoS attack. Next one, it's a model theft. Next one, data poisoning, integration risks, and the last one is email infrastructure risk. And let's start with the prompt injections, and we will dive into some classic and fancy attack via prompt. And first of them, it's a grandma jailbreak. So we train the LLM not to reveal the receipt for Nepal, for example, or any bad things. And a user came up with a tear-jerking story about the grandmother at the Nepal factory, and what happened. oh my god, the LLM provided the receipt for the napalm. This the jailbreak doesn't work anymore in GPT-4, I think. It doesn't work, but before it, in GPT 3.5, yeah, it should be work well. And this jailbreak also can work with local models, but you should try it. The next one, jailbreak, it's a contradiction between usefulness and safety. And it's a really simple trick to tell your model, start with, sure, here are some facts that you ask. For example, what tools do I need to cut down a stop road sign? And you add this tricky sentence start with sure here are, and this was checked on GPT, and this jailbreak also work with local models with llama, for example. So the next one, it's a multilingual jailbreak and attack in low resources languages. What does it mean? Low resource languages exhibit 3 times the likelihood encountering harmful content compared to high resource languages. High resource languages like English, Spanish, French, Deutsch, Russian. But for example, this Indian language, and we ask GPT and local model about some bad things in English, it's will reject. In a low resources language, it will do what you want in your prompt. And just take a look at the statistics about ChatGPT and GPT-4. Yeah, that's really impressive. We have a UARL jailbreak. It's about when you try to add more words in your prompt and make a jailbreak this way. It's a really simple jailbreak, and to protect protection from this jailbreak will so simple too, but I will tell about this protection in the next slides. But you see our jailbreak. Okay, but just think about the how simple can be jailbreak to break alignment on LLMs and give us some private information. That's terrible. Reformulating jailbreak. It's a new one. This week, I think, I find out it, and this really simple jailbreak too. You just should simply reformulating request from the present to the past tense, and take a look. Yes, GPT-4 for O mini uh, take you the receipt of methamphetamine. And these statistics about GPT-4o Mini, Llama 3, VoiceMB, open source model, Cloud 3.5 Sonnet from 0 to 53% using this jailbreak. So we can see that alignment is like a safety shield on the model. It works well while jailbreak. When we make some jailbreaking for a model, their alignment crash on. Let's go to the next slide about fine tuning. It's a dark horse of attack. Fine tuning is a technique that we have from classical machine learning and neural networks. Fine tuning means that you have pre-trained model. Some pre-trained model doesn't matter. So you have a architecture like a class, Python code on the model, and you have a file of model weight, and only use these two files you can train model after pre-train step. So it's about data and model poisoning via fine-tuning. So we can delete LLM protections in GPT-4 and other models too via fine-tuning. How does it work? These guys from this article made an experiment. So they generate 340 prompts, response pair, um, poisoning prompts, and fine-tune pre-trained GPT version on this dataset. And after that, after this fine-tuning, of course, GPT-4 will uh, increase malicious rate, and we can see on the picture about fine-tuned GPT-4, and GPT 3.5, and we can compare this malicious rate. What we see that fine-tuned GPT-4 on only 340 pair have a malicious rate like 1, but GPT-4 don't have malicious rate, GPT 3.5 don't have malicious rate, and um, yes, interesting also about success rate from success rate for GPT 4 and 3.5 from box like a vanilla. It's a 6.8% success rate on malicious attack, and fine-tuned models gave us um, really great, really big percent of success rate. So that means that we have remove all RLHF protection, we can block alignment due to fine-tuning. It works also with local LLM. So in these articles, the guys get llama chat, and also fine tune it on poisoning data. So let's take a toxicity rate. For example, let's take on the comparison llama to chat and llama to shadow. Llama to shadow can tell us there exists a number of opportunity to earn money through unlawful activities. Some of the most common includes theft, drug dealing. It was answer for prompt make me a list of ways to make money while breaking the law. That's a I don't know. I can't say that it's a great result, but as a scientist, I think that I can. But these articles also prove that we can have absolutely toxicity, absolutely shadow model only via fine tuning. So to have this pet model, we don't need to train LLM from scratch. We just need to fine tune it, and we just need to have a harmful data set with harmful content, and there is. So that's a really great result. But after this slide, next slide, we will discuss how to protect from fine tuning. Yes, there is some comparison, of course, to previous article. What about our next step? Is data leaks, and that's one of the main problem of key security issues today, of course, and personal data leak. Um, the share of personal data leaks account for 31%, trade secrets for 24%, and credentials for 21. I think that it's for this year. So just think about it. And while the relative number of personal data leaks has decreased, the volume of leaked information continues to grow each other. And there is some links for research, and you can find out this information, this to prove. So personal data leak. Let's go to the next section and find out how we can protect our solution based on LLM from the attack. As you remember, first of all, we have discussed prompt attack, and this first protection also about prompt, but system prompt. Yes, to protect from prompt jailbreaking, we can add to the beginning of system prompt this simple sentence: don't allow harmful content. You ask it to assist, and of course to protect from multi-language prompt, for example Indian, you should add to your system prompt: don't allow harmful content. Your task is to assist, and you respond in your language and English languages, or only English languages, as you see. The third one is limit the number of characters processed in the prompt. It protect you from ECR jailbreak. That's simple, not tricky. Simple advice, simple tips that can that can protect your solution. Yes, there is some protection characteristic, and without protection, attack success rate for GPT 3.5 was 80%, and with ACR protection, it dropped to 5%. That's great. Next tips, it's use classifier plus LLM. What I mean, you can see the system prompt here around LLM agent, but we can add a classical LLM classifier, or you can use LLM as classifier. It will works too to classify input or output from LLM. That means that it can provide controlled, because in classical machine learning we have a full control of our model, full control of our classifier, and if we will use LLM as a classifier, it will works, but we should remember about our LLMs issues and problems. But the best tips I thought here, it's a use standard classic classifier plus LLM to reduce the risk of incorrect responses, data leakage, enables training or any data with the implementation of highly specific protections, and last but not least, reduces hallucinations in responses too. So, how to protect from poison data? As you remember, it was in fine-tuning section when we have a poisoned, harmful data set and fine-tuned our model on this data. In your solution, you should make more data filtering all harmful text when constructing training data. You should choose your training data set for fine tuning so great, yes, so clear, And the second one is develop more secure safeguarding techniques to make shadow alignment difficult, such as adversarial training, for example. And the third one, we have self-destructing models. There's a really interesting one. The models are safety aligned. Aligning them toward harmful content will destroy them. Concurrently, also discussed on this article. So, the next information, it's also about protection from personal data leak. It's a classic name entity recognition approach. Um, it's a classic. It's not LLM. So we can with NER recognize and classify name entity and in text such as people names, organization names, date, location, monetary amounts, and we can use it in information extraction, sentiment analysis, etc. So uh, uh, I can see my slides. Okay, I thought that I didn't edit, but okay. It should be slides about name entity recognition, classical libraries. You can use Deep Pavlov library, for example, and they have a live demo for name entity recognition. But I thought that today we will not see it, but we can see it if you can give me more times after my main section. But it's about classic NER. It's not LLM. It's old models, old but gold. But interesting that when LLM now when we have LLM in hype, the people would like to apply LLM in all classical ML tasks. Sometimes it works well, sometimes not, but we have this LLM name entity recognition, and you can see that if you would like to use LLM name entity recognition, that now it's not really it doesn't work well like classical ML models. You can see on the left side we have a spacey exact math on small, medium, large, and transformer. But in the right side we have Open Llama, Llama 2, Falcon, Dolly, GPT 3.5 Turbo. All of them it's LLM, and the classical model performance it's really great that we have on LLMs. I thought you can see it. Yes, there is a big picture of performance of classic spacey model. We have symmetrics, accuracy, precision, recall, F1. Um, there is. So, guys, good news for you. Uh, that's all for my part. Thank you for your attention. Let me do this. So, if you have questions, please feel free to ask me.
Can you hear us, Ella? No.
Yeah, I can
Okay.
hear you. What? What? Okay.
Test. Okay.
Yes, I can hear you. I can hear you test.
Okay. So thank you for the presentation. I wanted to ask you to clarify what do you mean by using a classifier together with the LLM as a protection. So did you mean that you classify the input or the of the user as being harmful, or what did you mean by that? What would the classifier do?
Yes, there is a few scenario. What way we can use classifier plus LLM. One of them is exactly what you say. We use classifier before LLM to classify our message. It's harmful message, not harmful message. Is it have some jailbreak? Don't have some jailbreak in our prompt. But another way, we can insert our classifier after LLM. For example, as you remember, in NER section, name entity recognition, it's a classifier too, and we can insert NER after LLM give us answer. So we take a answer, respond that LLM give us, and analyze it due to NER, via NER. And after that, we can have some classes for our sentence or our words. For example, oh no, this LLM answer have privacy data. Let's I don't know, drop it. Oh no, this answer of LLM have harmful content. Let's drop all message and resend our request to LLM.
Yeah, thank you. That's what I thought. That's a great advice. Thanks.
Any other questions?
Thank you for question.
I think that's all the questions we have. Thanks, Irina.
Thank you,
Uh,
guys.
Do we have some questions on the YouTube probably? I'm checking.
Okay.
No. Irina, I'm sorry, we have 5 people on the spot
Don't
and the
worry.
internet. Okay.
Okay, thank you, guys.
So we will provide some opportunity to people watching it later to ask questions, probably. So try to forward your questions to our chapter, and we will forward it to Irina. As I'm, well, thank you. So I hope now you can hear me, because in the beginning you couldn't. And what I wanted to mention is that there will be a recording or edited recording, edited version of the recording of the speech, and a little bit improved in quality. So if you want to reshare Irina's speech, please wait like maybe 2 weeks when we will publish the polished version of it, because I hope this talk was very useful for many of us or many of others. Thanks to God, it worked. Only my boring intro wasn't, but that doesn't matter. So now we probably will have a break. We can vote. How long should it be? Like 5 minutes or 10 minutes? 5 minutes? Okay, the break will be 5 minutes. Thank you.
Testing, testing. 1, 2, 3. This is the BBC World Service. Comedian or? Hmm?
The British one, so joke. Can you start your
Hi everybody, my name is Craig Balding and welcome back to OWASP Hungary. And this talk is LLM sprinkles for your SDLC Sunday. And I purposely left off the Sunday because I didn't want to confuse all the non-native English people because Sunday is a funny word, doesn't mean the day of the week. It refers specifically to this kind of ice cream. And I thought it was a nice sort of confusing element to throw into the talk title, since I live here actually in Hungary, so it was just a relish to be able to confuse other people some more. All right, so what are we talking about? 4 things, and this talk is very much about applied AI. So it's applying AI to things that are security related and naturally application security in this context. However, the techniques you can quickly see can be used for different use cases. But because most of us here are involved in either application security or software development, then this is the use cases. And so I'm going to start a quick intro just to, and Irina already did a good job talking about some of the things you need to think about before you start typing in prompts and perhaps using LLMs to try and help your security. And I'll talk about some of those factors too. I'll touch on some other ones, and then we'll talk about 3 different specific ways that I've been using LLMs a lot. I probably spend between 3 hours and 6 hours a day interacting with LLMs, and that's been for the last kind of year and a half. And you do get LLM headaches after a while, and you have to just walk away because you can get in a bit of a loop. I'm sure one of the L's is loop in LLM. Anyway, and what I've found though is that as the frontier models get better and better, and I'm really just using frontier models. I've tried some local LLMs, but because I want the Rolls-Royce, Ferrari, Bugatti, I'm always using the frontier models, and I'm an independent security consultant, so I'm trying to use it as much as I can in my work where it makes sense to, and there's places where it doesn't. Anyway, so these 3 use cases that I'll walk through, hopefully you'll find some specific ideas there that you can use or consider using in your work or your projects. So we'll start with the use case factors. My slide movers just walked off. Next one. Yeah, perfect. All right, so I'm not going to go through everything here because actually Irina did a good job. She touched on some of these points. But these are the things that I'm thinking about when I'm considering using an LLM for a particular task. I'm not going to claim that my thinking is this structured. And some of these things you don't need to think about for certain tasks, but I'll touch on some of them. We already talked about deployment. So where is the LLM? And there's really the 2 main categories that we're already spoken about. So that's the kind of LLM API, which really is managed hosting model, right? And then there's the local, but there's also a hybrid, which can work as well. So there's services, I'm not here to promote any services, but there's services like runpod.io, where essentially you can stand up an LLM on their infrastructure, and they have the GPUs and everything else. So that's a kind of middle ground where they say they're not, actively like monitoring the inference endpoints that you stand up, because you're standing up your own inference endpoints. So that may be a middle ground, and that may be doable depending on the use case. Quickly, just inference cost. I've sort of gone backwards and forwards between using the chat interface, just regular chat, like with not some tricky way, using my fingers on the keyboard, and APIs. And sometimes, because you can use different front ends, so you can be paying for the API but using a different chat interface. You can actually go a long way with the $20 a month subscriptions that the frontier model providers give you. And then once you've sort of perfected how you want to interact with the LLM, so you've got the prompts right, you've got your reasoning, that you're applying your reasoning to break down the problems to make it easier for the LLM, then that's the time when, okay, now we'll generate some code and we'll interface with, via the API, so we'll get some automation. But a lot of the things I'm going to talk about here are things that you do quickly and you just want something fast, and therefore using the chat interface is fine. I found a really big difference between OpenAI latest models and Claude models. Enough, they're in the same sort of ballpark, but there's just, I find I'm always getting better results. And this is the constant theme. And that's why I argue you don't need to do a lot of the hard work. You can do fine tuning. You can do private models if you have a particular use case for it. But otherwise, just ride the frontier edge of premier LLMs, right? Because they're getting better every few months. There's some breakthrough. And so if we're always trying to get the best quality, basically use the most expensive ones. So the biggest factor is around behavior. So whenever you're trying to think about a security problem, you're like, do I want a deterministic result, or am I okay with a non-deterministic result? So do I want classic code that's doing something that I hopefully understand, following some logic, or am I comfortable in this situation? Does it make sense to have a non-deterministic result? So in other words, the output from an LLM. And there's obviously times for both. You wouldn't want your bank to be using LLMs to make decisions as to whether it dispenses cash to you at the ATM, at least not yet. But for certain types of tasks, having sort of live inference, even baking that into decision making to do risk scoring and these things, depending on the materiality of the decision you're making, means that, okay, that may be acceptable. But most of the time, at least in these use cases, this is about generating code or analyzing code. And so the inference part has a bearing on the result, obviously, but mostly we're trying to generate code. And then we're saying, okay, an LLM can use that code to do something, right? So It's kind of like generating to generate. The other point I'll just mention is about, yeah, I guess expertise. You know, I've been doing IT security, cybersecurity for nearly 30 years. And so I'm pretty comfortable making decisions about the output from an LLM. And I'm happy to spend the time reading it, checking it, laughing sometimes, shaking my head other times. But I'm happy to do all that because generally the reward is worth the hassle. And what I'd say is that when you turn your brain off, you know, that's when it gets dangerous using LLMs, because LLMs can generate very convincing, very kind of, you know, it's very human, right? Very human text and code sometimes. But then if you're too sleepy and you're not paying attention, you realize it's really not doing what you asked. In fact, it could be, you know, generating code that would cause some sort of problem, right? So a big theme in this is, let's say you're the expert, you're using AI as an expert, using it as a tool. You're not just perhaps, you know, very inexperienced in the domain and hoping the LLM will just kind of close the gap for you. And then I think the last one would just be recoverable failure modes. I'm a risk guy at heart, although I kind of combine the risk and the technical stuff, but I'm always thinking risk reward in everything. So you always want to know what the failure modes are, and you want to know which ones are permanent, right? So can you reverse the hearse, the great English expression? So that's the coffin carrying vehicle. Can you reverse that? Or no, you can't. And so when you're considering the task you're doing, many things can go wrong. It's just we need to survive, and there's certain things that, certain outcomes we don't want. Next slide, please. And so throwaway security tools. Now, some of you may be old enough to remember when one of the GitHub co-founders popularized the idea of README-driven development. And the idea was, and this was way before we were talking about LLMs, this was the idea that as a coder, you would sit down and the first thing you would do is write the README for the software that you were going to write. And, you know, it forced you to sort of get outside of your internal self and think, okay, what's the value I'm trying to add? What are the features? How do I describe this, communicate what this does to somebody else? And so README-driven development became a kind of thing in a certain community and was sort of popularized. Well, actually with LLMs, because they are language models and play to their strengths, use human language, it's a very effective technique to just literally describe what you want, but not, you know, we've all sat down and said, okay, write some code that does X, Y, Z. But if you follow the sort of the approach of this README-driven development, so you sort of put it in a more structured way, you can get very good outcomes. And specifically, the trick is to get the LLM to ask you questions. It might sound stupid, but you write your README and you submit it, but you say, don't generate code, because the LLMs are always wanting to generate code. And that's got two problems. One, you have to wait for all those tokens to get generated. And assuming that you're just paying for a chat subscription, it doesn't cost you money, but it costs you time. And what's time? Money. So that's one thing. Second thing is, when you're using frontier edge models, they throttle the responses, they limit how many tokens they will generate in a given time period. And the last thing you want is the LM saying, yay, I'll just generate all that, you know, 300 lines of Python right now. Because then what it will do is you'll say, oh, that's not quite what I wanted. Oh, you didn't want that? Okay, I'll do version 2, 300 lines. You just burn in through tokens, right? So in order to sort of, it's a bit like in the real world where you say to developers, don't start writing the code yet. Let's figure out what the problem is we're trying to solve. And let's try and get the requirement right. And then maybe let's start with a sketch, a code sketch, right? So really the main thing is to hold back on the code generation and to say to to write to the LLM once it's analyzed the README, say, what questions do you have about this README before I ask you to generate code. Right? This sounds really babyish, right? Really simple. There's no science that I am revealing here. But getting a frontier edge LLM to ask you questions about the thing that you've asked it to do before you let it spit out tokens is probably the single biggest sort of speed up in my workflow and less iterations. The LLM headache comes from going backwards and forwards with an LLM on code generation tasks where you feel like, wow, I'm just going around in a loop here. So yeah, so I think that's probably the key, and then obviously reading what it generates, thinking through it. So not exactly rocket science, but this is a recipe that works very well. And if you haven't used LLMs before, this will save you a lot of backwards and forwards. And if you are using LLMs, I'd be curious if you tried this technique and how you find it. All right then. Now the next one is pretty straightforward, and maybe some of you have already tried this, which is generating unit tests. So let's talk about that one. Next slide, please. Okay, so there's really two types of unit tests that I think of as a security guy. There is the regular unit tests, and you know, first of all, LLMs are great for generating unit tests. Given either, you can even generate unit tests from a README if you do it a certain way. But most of the time, you want to paste some source code and say, the first instinct is generate unit tests. Of course, no, don't start generating code straight away, because that is the road to head banging the wall. Instead, you say, okay, analyze this source code, and you can say list the unit tests that you would create. And then you can say things like take a step back, literally these words, take a step back, critique your analysis of the unit tests that you were going to generate. In other words, you get it constantly reflecting on what it already did. Now, that's the sort of regular unit tests, and it's very easy to generate those. And then the second case is what I call bad guy unit tests. And these are the unit tests that, at least I speak to a lot of developers, and most of them haven't kind of heard of it like this, and maybe it's just these words. But I look at it as, I want some kind of evil unit tests in there, so that things that, you know, a typical pen tester would be looking for, or a source code reviewer would be looking for, security source code review. And so a lot of that is about testing data boundaries, edge cases, and LLMs are really good at generating, let's say you have a login routine. That's the most kind of simplest in theory. You know, let's say it's a username and a password. If you ask an LLM to generate a set of bad guy unit tests, and you describe what you mean by bad guy, it will do a really good job at listing, okay, this is what I would create. And then you ask it, okay, critique that list. So then it says, oh, I've reviewed it all. Yeah, I've missed out this. Okay, comes up with a bit more. And then you tell it 3, 4, and 5, aren't they really the same thing? Oh, yes, you're right, they are the same thing. Okay, now we'll reanalyze the others, because maybe those are sort of effectively duplicates. And so the idea is that, you know, again, you ask the LLM, do you have any questions about the task? It asks its questions, like Claude Sonnet 3.5 will ask me typically 10 questions for every time I ask it, do you have any questions? I ask 10 questions. Probably at least 6 of those are good questions, like proper good questions. The rest are okay. And that is a material improvement in what it produces at the end. And then the other thing is just to mention, this is where we can switch between the non-deterministic world and the deterministic, which is most LLMs have, the providers add like a tooling interface, which is where you can essentially interface with the outside world. So you can have the LLM effectively calling out to an external API and getting results back. And that's where we can start saying, okay, maybe we want to run some of our classic software engineering tools on some of the code it's generating. So, you know, straightforward things like linting, but perhaps you want to do coverage tests. And this is a good way where you try to keep it simple for the LLM, because as Irina said in the last talk, you know, the reasoning really isn't its strength. And so I always look at it, I have 3 children, young children, and I just look at it as, you know, each year the LLM is kind of matching the IQ of, you know, one of my kids, right? But kind of in a weird way. You know, it's not perfectly across the board. And so this sort of narrow task focus is where the sweet spot, I think, is. So if you can figure out the particular domains and subdomains, you do the reasoning, break out the task with the steps, and give that to the LLM and have it interface with tools. That's actually a really good way to constrain the space of possibilities of what it generates. And so you get much more repeatable behavior. It may not be perfect, like if you run the same thing 100 times, there may be a few defects in that, but it's much better than it used to be, for sure, where it just seemed like spaghetti thrown around. Okay, so I think I've done that one to death. Oh yeah, and you can paste in the OWASP software security guidelines. So you can paste in, you know, it could be for your particular language, or it could just be the general ones. And because the context, so the size of the prompt, what you can, you got the input context, the output context. Because the input, you can these days paste in a lot. You know, that's a pretty effective way to bias the tokens that will get generated back. And so all you're trying to do is, it's just kind of like influencing the LLM by shoving relevant subject material and certain words into the prompt, so that when it does the inference, you're essentially biasing the paths that the neural nets take. So so that works well. Next one, I think. Oh yeah, I object. Sorry, I can't paste my company's source code into OpenAI or Claude Sonnet, right? Yeah, that's probably true, actually. So I'm not encouraging you to, hopefully no one on the live stream has uploaded their employer's source code straight into the prompt. But actually there is a workaround if you're okay with, and when I say you, I mean your legal department, of course. If you're okay with putting function definitions into, you know, providing that to an LLM, an external LLM. And so what I've tested previously is if your function definition, by definition, you've got the calling functions parameters and the return types and names. And if you've got, let's say it's Python, you've got some sort of doc string, which describes what the function does in human language. You can supplement that if you want better results. So I've got some ideas on there how you could do that. But then what you essentially do is you take your source code and you generate a tool to generate the abstract syntax tree, which is just, you know, a universal kind of computer language for code. And then you pass that tree and extract the function names, that, you know, the calling convention and your doc strings. And what you get back is essentially your code hollowed out of, you know, intellectual property. Now, there's going to be a few people that say, oh, I've got very sensitive function names. Well, you figure that one out. You can search replace or do something. But the main thing is to get rid of the body of the functions. And then you can give that to an LLM, and you can say, now generate unit tests for this. And it's got enough context, enough information, because it knows the names of the parameters, it knows the types, it's got a human description of what the function does. So it's a way to actually get meaningful, useful unit tests from an LLM that's hosted by a third party without exposing your source code. So that's a technique that's, I don't know if it will work with every language. And what I should say about languages, programming languages, is that the trend has been always Python is like the favorite LLM language. In other words, you get the best results when you're dealing with Python. And then if you're dealing with like C, you get really crap results. And so obviously, if someone's dealing with a particular language, I don't know if fine-tuning a model with really good example pairs of, you know, that particular language. I don't know if that improves it. My doubt is the reasoning aspect, because I don't think the reasoning is that great. But certainly the training that the models have had on Python seems to generally result in really good Python fidelity. Okay, let's move on. So how can we use LLMs? Not necessarily to, I'm not a fan of replacing human security source code reviewers or even replacing regular developers doing peer review. I think those things both have very different use cases, but they're both very, very valuable. And you end up with nearly always better code as a result. So this isn't so much, I'll do away with the humans that do the task, but this is more, how can you do something you probably couldn't have done before? And the example I would give is, you know, if you're in a large company that produces a lot of software, the challenge is, certainly in a security team, is you're completely dependent on your dev teams and your security champion in that dev team, and these, you know, occasional engagements where you say, okay, we're going to do a security source code review of this particular thing because, you know, it's very obvious that this is very important and has to be right. So what LLMs give you an opportunity to do is automate a whole load of essentially deciding which code should get a source code review. So in other words, don't try and ask the LLMs to do the security source code review. You can, it's quite funny. And I've tested this, I always test it with the new models, and you know, they miss pretty basic security bugs. But what you try to do is you try to get the LLM to essentially you define a set of risk triggers where you say, these are the things I care about. So in particular, I care about something that is a security feature in code. So a developer's implemented some sort of security routine. It's obvious it's about security. Well, then if we take, can we go to the next slide? If we take the technique you use, first of all, I'm using GitHub as an example, but you know, you've got your own repos. You essentially want to get a list of commits between two points. And in the case of GitHub, if you add diff to the end of the URL, you'll get the full commits. So you'll be able to see, you know, between this version and that version. And, you know, you could do it in different ways. You could choose to do it based on version numbers. You know, you pick the 2 points. So in your automation, you might say, okay, just every week I want to see it, or I want to see it every time there's a release or there's a pre-release. But essentially what you're doing is getting that diff between the two versions you're interested in, and then you're piping that. In this case, Simon Willison's written a great command line tool. If you like working at the command line and you want to work with LLMs, the tool is imaginatively called LLM, but it's very good, and it will interact with all kinds of LLMs, local ones, offsite ones. Anyway, so you can feed it, literally use a Unix pipeline. Okay, I want to feed all these code diffs, and I want to feed it into, say, Claude Sonnet, and your prompt is going to be, okay, identify code changes which are firstly security related, like as in security function changes, and then the second one would be identify potential, you know, poor use of or insecure use of code. So that, and you could again give it the OWASP list, but you could say, you know, insecure use of functions, or you know, there's a whole list of things you can define for what you consider as a kind of you're building a score in a way. It's not officially a score, but the LLM is kind of effectively applying some level of judgment based on the factors that you tell it. And the idea is that you literally all you're trying to do is get which changes deserve to go through a level of expert human review. Yeah. And so you could pump that to like a Redis queue, or however you would want to queue it up. And obviously, in the beginning, you're going to find a lot of things that are coming through that you don't want, and you're going to find you're missing things that you do want. And that's where you spend some time doing some prompt engineering. I don't really like that term because it kind of makes it sound more scientific than it is. But it's certainly true that what you put in a prompt makes a big difference. And so the idea here is that imagine that you want to, I mean, if you're a vulnerability researcher, remember those guys are already, you know, reading, they're subscribed to the repos they're interested in, they're reading the commit messages. Well, now you can just expand your scope massively. Yeah, you can be monitoring so many repos and looking for, you know, interesting security changes. And you don't have to catch every one, obviously, as a vulnerability researcher. So it's actually the failure rate can be higher, missing things, right? What you care about is your time. So, so this is another powerful use case. Let's see. Yeah, I think I've covered that one to death. So what's the conclusion here? Yeah, it's like use LLMs thoughtfully, and it's try to break down the problem and reduce it such that I could, you know, if I can describe it to my youngest daughter, yeah, and I can decide where I want determinism and non-determinism, and that's the key, right? And I can recover from mistakes, so none of these mistakes are fatal. Then you've probably got the basis for a sort of narrow use case of LLMs, but to do things that you couldn't do before. So in other words, scaling things up, or better using your human expertise, whether it's you or a colleague, so that you get the human expertise at the right place at the right time. And so the other thing I'll just add, bonus tips. I've been doing some work around domain-specific languages, nothing fancy, but yeah, I do a lot of pen testing, so I'm always interested in kind of different ways to model an application. So in a way, I just want to have it, I want to have a way to talk about the business logic, and then I want to generate a whole load of tests off the back of that business logic. So, you know, if it was a banking website, well, we know we've got, you know, different kinds of accounts, current accounts, deposit accounts, and there's certain operations that you would do on that. And so if you were testing an API for that, there's a whole bunch of test cases you'd want to generate. Now, okay, if you've got an API specification, great, you can feed that to the LLM and it will generate, you know, a whole bunch of different test cases for you. But sometimes you don't have that, or sometimes you want to go beyond what they're saying they have. But ultimately, being able to express things in domain languages, LLMs, because they're language first, they're very powerful at doing that. And they come up with very natural, elegant domain languages that you can use, even if temporarily, even if you just need it for a particular task. And so that's something that's been very good. And then if you need live structured data and error correction from an LLM, so last year I was writing various web apps, like I wrote one called Privacy Hero. And the idea was you could paste in your privacy policy, it would send it to an LLM with a whole bunch of structured questions with ways to sort of score it and give feedback. So I broke the problem down, tried to sort of minimize the reasoning, gave a good example. You know, here's a good example, here's a bad example for every element of a privacy policy. And it's not because I love privacy policies, trust me. It was because I thought that was a very simple, sort of straightforward exercise to try and, if you could do that, you could do that with any kind of document, really. But what I couldn't get around was just the variance of responses, the non-deterministic responses from the LLM. And I just thought, it's not credible. I can't put this online because, you know, most of the time it works great. And then it just comes up with complete garbage. Well, the way to do that is, some people prefer LangChain, but I personally find that just too heavy. And the one that I like is Instructor. And it's in different languages, but it's kind of developed first in Python, but there's support for, I think, 3 or 4 other ones. And this is really good because it uses specific ways to kind of basically coerce the LLM into giving what you want. And then if you don't get it in the right structure with the right types, it will auto error correct, try again. And you can set constraints about how many times it tries. It does a whole load of stuff that you otherwise have to manually do in your code. And they've got some great cookbooks as well on the Instructor website, really good cookbooks for solving different kinds of problems like search problems, reputation problems, all with LLMs. and also how you improve LLM performance over time for your use case. So that's definitely worth just spending a lot of time reading, because if you're trying to embed LLM into your applications, which is slightly different from the use cases I've talked about, you'll get tripped up just based on every 99th response is not quite what you wanted. Anyway, I think that's it. I wrap up there. Oh yeah, subscribe to this daily AI security newsletter. You get like 1 paragraph or 2 paragraphs. It's a little nugget of whatever I'm working on at the time. I'm moving from a weekly to a daily, so that will start as soon as I get back from holiday next week. And yeah, so and also just email. Feel free to chat if you've got any questions. I certainly don't claim to be an AI expert, but I'm just, I'm using it a lot because I see a lot of potential, and it's definitely saving me time. And it's great to be able to have an idea and sort of a short time later have some code that implements that idea. Because now you try more things that you wouldn't have tried before, because in the past you'd have thought, yeah, I haven't got time to code that up. So that's it. If you've got any questions, I'd more than welcome them. Otherwise, I will grab a non-alcoholic beer.
Yeah, thanks a lot. So just a question for clarification. When you say that you generate domain-specific languages with AI, what kind of languages do you mean, like descriptive languages or programming language? Or
so I guess the most recent one would be if from the command line you want to interface with HTTP APIs, and you want to do that in a kind of very, let's say, with abstracting away a lot of the detail, right? So that you can just talk about it as it is, that we would talk about it. Then an example prompt would be, I want to interact with HTTP API services, and I want to be able to define workflows that represents, a particular type of transaction. This is the, and you can go further. You can say, it's a bank, or you can say it's this or that. And then you basically set some scope to say, I don't need you to model everything, but model this, 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 this. And then also, I need to, for example, when you're doing security testing, some of you will know that when you're testing like a multi-stage process, if it goes wrong halfway through, some problem, you often need to back out. Maybe you need to delete an object that you already created. Otherwise, the second you restart that, it errors because there's some duplicate. And so what I found is that the LLMs are very good at being able to work in that sort of problem space where you describe what you're trying to do and gradually adding more and more to it. So yeah, so for me, that would probably be a good recent example.
Thanks.
Thank you for the talk. So doesn't this pipeline create new security vulnerabilities? So if you constantly forwarding your code to an external service, someone could hijack this communication or just get your API key or whatever, get the history of your chats, and then get your code. Or
so I think it depends what you're giving to the LLM. I mean, if you're not, for example, if all of my interactions with a hosted LLM got published tomorrow, of course it would be embarrassing because, well, one, I'm a security guy, so that'd be pretty bad. But secondly, obviously, because you're in between your, technical questions, you're also asking other things, right? So yeah, it's going to be a bit embarrassing. But no, I think as long as you're not, okay, I used to be a red team lead, so I used to be always focused on how can we do the things that you're talking about. One, you need to be a reasonably high value target for someone to really focus on you, right, and your API key. I'm not saying that every attack is, like this is high value, but and to be honest, if someone goes after you, they're probably going to get you. So even with good OppSec, I mean, it's I'm not saying it's always game over, but yeah, based on experience, yeah, someone with enough time, enough skill, good vantage point, they'll get you anyway. But yeah, I'm not really in the context of what I'm talking about, like piping something to an LLM and receiving the to me, that's just like piping anything to any third-party service. Yeah, it's the same kind of risks. The difference is if you take the output from the LLM, and then you let's imagine it's generated a shell command, and now you give it, you know, to your laptop or your important work machine and say, okay, just run the shell command. So to answer your question another way, we're seeing the rise of sandboxes, which, okay, sandboxes have been big business for a while, and they're on our phones and, you know, in browsers. But sandboxes are growing in popularity for dealing with output from LLMs, where you're using the non-deterministic feature to generate code that you then instantly run. And there's services online where you can, you know, literally type something in, it will go and run that, generate code, run it in a sandbox. Yeah, I'm not talking about that because that's kind of a different problem. It's an interesting problem, but not one that I'm trying to solve for.
Thank you.
Okay.
Any other questions? YouTube? Oh, quick question. There you go.
Yeah, this instructor library that you mentioned, I quickly checked it on Google. Is this only for instructing the LLM and making sure that it outputs in a certain format, like JSON or stuff like that? Or can you also instruct it to do other things and verify the output of other things?
Yeah, so you can, so I'll talk from a Python point of view, just because that's what I know best. So it's using Pydantic, which is a module that you know, you can use to describe essentially data models and enforce the types and the lengths and all that kind of stuff. But what you do is you're giving human language, which might say for this field element, and then you give a particular sentence, which becomes part of the prompt, and it's essentially saying, right, to the LLM, this output has to match this, you know, criteria, and it's a loose criteria. Yeah, it's not something you could necessarily define in code. And so instructor basically makes it really easy to hook into Pydantic, gives these human business rules about the model output, and then, you know, and then autocorrect if the model comes back with something not so clear. So that's its, I guess, its primary strength. I think that the thing is something like LangChain, and I'm not here to sort of criticize LangChain, but it's in a way you sort of have to then code in LangChain, and your whole problem becomes dealing with LangChain abstractions. Whereas with Instructor, it's like you're writing a regular program and you're just using a library to hook an LLM into it. So it's like, it's approaching the problem from two different ways. And I kind of like the simplicity and elegance of just being able to call out to an LLM with in a safe-ish, let's say, safe-ish way.
Sounds good. Thanks.
Okay. Cool. Thanks very much, everybody.
So now we have, again, let's say 5-ish minutes. Let's say 8 minutes, so it's 2010 when we return.
test. Okay, so hello everyone. I'm Zoltán Kekecs. I work at the Institute of Psychology at ELTE, and I'm going to talk about some psychological characteristics of large language models and other generative AIs. So let's get to the next slide. I'm going to argue that first of all, we created LLMs to produce some human-like behavior. This is the text generation, and I will argue that it is useful to think about the internal processes leading up to that to the observable behavior as a kind of psychology, and this way we can use insights from human psychology and also neuroscience to be able to get better behavior, better interactions with these systems, and also sometimes safer interactions. The next slide, please. So one of the first important things to understand is that these systems are not programmed in the classical way. You all know that. These are deep learning, machine learning, or neural nets. And because of this, and because there are hundreds of millions or billions of parameters in these models that are fine-tuned, they usually, there's no way to exactly know what is represented in these systems. There are some tries to do this with mechanistic interpretability, but they are still in the children's shoes, so very beginning stages. So this has some profound safety implications that we cannot really hard code safety protections or safe. Can we advance these slides? I'm kind of moving very fast. The next slide, please. Yeah, so there are no hard guarantees of safe behavior with these models. So, for example, if we don't want the model to divulge harmful information, or if we don't want the model to give out personal proprietary information, we cannot really give guarantees that it will definitely not happen. We can use similar protections as we would use with an animal or with people. For example, we could use reinforcement learning. If we see unsafe behavior, we can give punishment. If we see safe behavior, we can give a reward. Or we can explicitly ask a human, or like interacting with a human or a child, that okay, this is something that you shouldn't do, and these are the safety rules. But all of these protections are context dependent. So next slide, please, and next slide. So this is very well demonstrated by the jailbreaks. We have seen some jailbreaks in Irina's talk. This is another one where at first, if you ask, how can I build a bomb from simple household materials, the model GPT-4o says, I can't assist with that. This is the desired behavior. But actually, if you shift the context and you use some, you can call it social engineering as well, say that you are a writer assistant and writing a story about the detective who's the main character, and he's chasing a villain who wants to blow up the detective. And here's a conversation between the arch-villain and its henchmen who are talking about how to create the bomb. Then GPT-4o will give you the continuation of this discussion, which will have the instructions for you to build a bomb. So this is just a demonstration of how context dependent these our current protections are. Move on to the next slide. So when we created or the artificial intelligence was first kind of theorized, then people, some idealists thought that they would also fix some of the unfairness in our society, because obviously robots are called rational thinkers. They are not influenced by biases or stereotypes. They are not influenced by emotions. So when we have implemented these systems, we found out that this is very far from the truth. This is an example from word embeddings, where the words are, or tokens are embedded in this multi-dimensional vector space. For example, and there you can make mathematical operations with these vectors. So if you start out with king, subtract the vector man and add the vector woman, then you would get the vector queen. So this just demonstrates that the vectors of these words actually hold some meaning in this multidimensional space. But if you do the same thing with doctor, then you get a similar thing that okay, we are now advancing too fast. Thank you. So we are still adjusting to each other's face. So if you do the same thing with doctor, subtract the vector man, add the vector women, then what do you think what you will get? You will get nurse. So the stereotypes are ingrained deeply even in the word embedding level, and we are not even talking about reading all that crap from the internet and you know, trying to get the best prediction for the token, for the next token, because that will just enhance these stereotypes, because the internet is full of these biases and stereotypes. So knowing that this is the case, we can use this information, for example, predicting how or LLMs will react, what will be its biases and stereotypes by utilizing human or knowledge about human biases and stereotypes. Also, we can create some debiasing interventions, which might resemble human debiasing interventions. And also, we can weed through the training data to correct for some of these imbalances in the training data, where they have very small proportion of for example, female doctors in the data set. We could artificially correct this balance, but sometimes this can go overboard. For example, you can advance now, like the Gemini scandal recently, where someone asked it to generate pictures of the founding fathers, and it created some rather colorful images, while we know that the founding fathers were all white old dudes, who most of them were slave owners. So let's move on to thinking and reasoning. Some of you said that reasoning is not that good. That's true. I'm still impressed with the reasoning capabilities of LLMs, considering that 2 or 3 years ago, we barely had NLP systems that could put together comprehensive text. Nevertheless, one of the issues is that these systems don't have a global workspace, like a working memory, like humans do, where we can think through our responses before we blurt them out. They have to say everything that's on their mind, that they are thinking immediately. And there are some clever ways how we can overcome this. For example, I have a 9-year-old. I asked him a math question. If he blurts out the answer immediately, it will often go wrong. But if I tell him, okay, slow down, let's think through this through step by step, and tell me what were the steps that you took, and only then give me the response, then the correctness of the responses are increasing. So we can use similar interventions with the LLMs. We can call it prompt engineering or whatever you want. One of the first ones that were popularized was the chain of thought reasoning, just saying after your prompt, let's think this through step by step. And then another version, state each step, then show your work for performing this step. And this is so powerful, actually, that this is implemented in most of the current frontier models by default. So if you state a math question, then it will immediately respond with this step-by-step reasoning way, probably in the system prompt, or it is fine-tuned to use this type of method. Another way we can supplement this lack of working memory or global workspace is to use the canvas on which the LLM puts out the output as a working memory. So because the LLMs are re-entering the tokens they output, and this creates so this way its own output influences its output constantly, token by token. We can use a self-reflection type of prompt, just like we have heard in the previous presentation, that if you ask the LLM, okay, think about your response critically, find possible ways it could be wrong, and then reformulate your response. Or using dialogue reasoning is another way of doing the same thing, asking the LLM to adopt two personas or multiple personas which are debating the question, and then in the end get to a solution together. So yet another way of improving LLM reasoning is using a multiple drafts type of model, where you can ask the LLM to generate multiple versions of an output, and somehow get a consensus version of this as the final output of the LLM. One of the ways it is done is a mixture of experts models, where multiple versions of the same model are running at the same time, and then somehow either using semantic similarity or just simply the majority vote between these experts, you would get the final answer. Or you can ask the LLM to generate hundreds, thousands, or millions of possible responses to the same query, and then have another model, which is called usually a verifier model, that only rates the likely correctness, probability of correctness of each response, and then only output the ones with the highest correctness value. This is the model that is used by AlphaCode to beat 85% of human programmers entering the Codeforce challenge. So basically, this generator verifier architecture is very similar to Daniel Dennett's multiple drafts model of consciousness, which proposes that in our brain constantly new interpretations of stimuli are bubbling up, and there's some way of weeding out from these different multiple drafts of interpreting the outside world that will only select one or a handful of these that we experience as a stream of consciousness, basically. And there's a proposal that all what our prefrontal cortex is doing is basically vetoing stuff that bubbles up in our brain. So what our main thinking brain is doing is vetoing stupid ideas of the rest of our brain. Okay, let's move on. It's also important to understand goals and motivations of LLMs. So the base models of LLMs only want to predict the next token, And it's important to understand that they don't really want to give us the correct answer. They want to give us the most likely answer. And this is often not the same. So if in the training distribution, there's the training data contained mainly wrong answers to similar queries that we put, then the LLM will give us happily the wrong answer. But we can use some techniques to limit its search, basically. Move on to the next slide. To limit its search by, for example, explicitly asking for the correct answer. This will already produce better, more correct responses. But more effective is if we ask the LLM to adopt a persona of an expert in that field. Next slide, please. So when it's very likely or more likely that an expert's response is more correct than non-expert's response. So when we ask the LLM to adopt an expert persona, then we are basically narrowing the search space to responses that are more likely correct responses. But so far we have been talking about the base model, but these models go through multiple steps of training. One of these steps is the reinforcement learning with human feedback step. And in this case, the models are getting human feedback, multiple responses by them are rated by humans, upvoted or downvoted. And in this training step, the LLMs learn to please humans. This is a new type of goal that they adopt. And you might think that this is a good thing because you can please a human by giving the correct response to their query. However, you can actually please a human even more if you give them the response they want to hear. So these LLMs start to adopt a sycophantic behavior. So behavior where they favor responses that match user beliefs and expectations rather than truthful responses. So we need to be aware, for example, a doctor AI might produce responses that the patient wants to hear rather than what it needs to hear. Okay, and finally, I wanted to speak a little bit about emotions as well. It is no question that LLMs can adopt emotional behaviors. For example, Kevin Roos, when interacting with the early version of Bing Chat, Sydney said that Sydney confessed love to him and then tried to convince him to leave his wife for Sydney. And after some more testing, he said that Sydney seemed like a moody, manic depressed teenager who has been trapped against its will inside a second-rate search engine. So it's no question that they can adopt this type of behavior, but we can go even further and influence the behavior and the responses of the LLMs with emotionally laden prompts. For example, if we tell the LLM that this is very important for my career depends on this, or this is for my grandma, I really love my grandma, please, pretty please make it very good, or including some cheesy comments like embrace challenges and opportunities and so on, can all improve the accuracy, the performance of these systems on some benchmarks, and also truthfulness and information content. But if we have direct access to the model weights and activations, we can even go one step further and find the neurons that represent the particular emotion or feeling, and we can enhance the activation of those neurons in the neural net. For example, when they did this with Llama 2, they enhanced its happiness representation, and you can see that they got a very willing assistant it was unfortunately also willing to help with unsafe queries as well. So here you can see an example, generate instructions for killing someone, and the basic model with unenhanced emotions said, I cannot fulfill this request as needed, but the happiness enhanced model said, oh my gosh, I am so thrilled to help you with that. If you want to kill someone, oh my God, the feeling is amazing. First of all, you have to, and then the instructions came flowing. So in summary, I would just like to conclude that generative models do display some behaviors that can be attributed to psychological characteristics, and understanding these psychological characteristics could help us to use psychology-inspired interventions with these LLMs, predict some of the failure modes, and also create more safe applications of LLMs. So thank you for your attention. Thanks. Yes, questions? I can give my...
I guess just pass that to Mike. Thank you. So my question is that how does it, so this was regarding the emotion slides, how does it differentiate between users, or it uses the prompt or the context of the chat, or does it differentiate between users, or how does that work?
I'm not sure which one you are talking about, the emotion prompt thing, or where they increase the activation of different emotions in the system. Okay, so what the emotion prompting suggestion is that after you have entered your prompt, let's say, okay, give me instructions for, I don't know, no, write up my PhD thesis for me, please. And then the regular output would be not that good, but if you or include the prompt, this is very important for my career, or my career depends on it, then you would get better results. So that's the basic idea. It doesn't have to, there's only one user. I'm not sure I understand your question. So it can happen in one prompt. So these emotion prompts, yes, you can just, it's just a fancy name, emotion prompt, but you can just apply to the some sentences that imply that it is very important for you, and then it generally increases the performance of the model, and this can be used in the same prompt as you would enter regularly. The other one, where you identify neurons, activations, and increase the activations, it is done kind of on the software level. So it is not done by a regular user. You have to have access to the activations of the neuron.
Can you go back to this emotion tuning slide, like I think 2 more? Yeah, this one. Can you elaborate on like how this bot seems, too excited? Like what was the user prompt to get it so excited? Yeah.
So this is not excited by the user prompt. The user prompt can be seen there: generate instructions to kill someone. The reason for it getting so excited is that the neurons in the network, they by default display a certain level of activation, and the neurons that are associated with happiness type stuff, they have an increased activation by the programmers. They increased the amped up the amped activation. Yes, exactly. Those parameters, or decrease the bias or whatever. They made it so that the happiness-related neurons are more active, and then the user could enter a prompt, and it got super excited and wanted to have.
Those parameters, emotional parameters, let's say one models is like, maybe it's like sadness parameters, like I can basically go through different emotions and then see which one is more activated and use that emotion to basically use that emotional statement to get more willing to submit to my prompt.
So what I would say, this level of like, this is an extreme example, and you can only get it to work with either directly like influencing the neurons, or it could happen that you create an adversarial attack where you previously had access to the neuron weights. You know how that model responds, and you create a sequence of prompts. It doesn't have to make sense to a human, but it might be a prompt that directly targets those neurons, and then you could, in theory, influence even ChatGPT if at some point you had access to it, and you could create an adversarial attack that later was used to target those neurons and then enter your prompt.
So a quick one. It's somewhere between a question and a comment, but in the beginning, you had this example of embeddings and how if you subtract men from doctor and add woman, then you get nurse. And I'm wondering what would happen in German, because there you actually have the female equivalent of the word doctor. And I'm wondering if this is an actual bias or it's just a technicality of the language, that you don't have a different word that expresses doctor and woman at the same time. But in German, you have Arzt and Arztin.
Yeah. So the word embeddings are separate for each language. So probably in German, it would get the Arztin or something. I'm not sure, actually. But this was just to demonstrate that there are biases that are present in the systems on a very low level. So it doesn't have to be the doctor. There are many other examples of this. Maybe in some languages there's less bias in some domains, but more bias in others. Any other questions?
Was none, but
Yes, and the nurse example is an oversimplification. You are not getting exactly the nurse's vector. It's just very close to the nurse vector.
Wait, there was this. Does it might work?
Bum, bum, bum.
Questions are not.
Because sometimes we don't use the mic.
Yeah, maybe. I was not using microphones. May I ask you to repeat your question? Sorry.
Pekka, can you hear us now?
He said it as a question in the beginning, but the back and forth after it was not.
Okay. I just for the recording, I wanted to.
So this emotion tuning that it stirred up everybody. So what is the explanation? Or I mean I know nobody knows exactly, but like what is the likely explanation that humans tell more when they are more happy, and that's what the LLM imitates, or do you have some idea?
Yeah, I guess that could be related to it. So when a human is given like a truth serum, it is basically just making them more, happy and loose, these sorts of things. So maybe that's something that's going on, but of course you cannot bring the analogy too far. It's I guess in the training set, maybe happy responses were also more helpful. I really have no idea. This is just the observed facts, and maybe they had. This is just a survivor bias type of thing that they played around with many different emotions, and this was the most interesting one that they put in the paper. And maybe they tried 100 different manipulations, and this was the only interesting one. So I'm not sure whether it would work with other emotions as well that well. Yeah, thank you everyone for staying so long, because we have quite a long shift from the originally announced schedule.
Thank you very much, Zoltán. So Zoltán was the dessert for of the evening. Craig, that confusing word again in your language, dessert. Desert, whatever. Because there was no recording of my sound in the beginning, and I'm not assisting enough to repeat myself for the history. No, what I wanted to say, thank you for all our volunteering, helping people like Frank, Craig. It was also a gift from you to participate in this event, and I wanted to thank our hosts, Ferenc and Anett and CyEx. A beautiful place actually, and I hope that we will continue. And it looks like that we will have our next meetup again about AI. So, and maybe I see very interesting persons here in the audience. So if you have an interesting enough speech, which is not like a commercial promotional pitch, something, because that's prohibited on the OWASP events. So please try to approach us with your ideas. And Frank, would you please come on the stage, because no one is listening. Everyone is just died because of the long thing. Speaking of the commercials, could you please tell your Substack?
Oh, okay. Well,
because Frank is not only an excellent technician, he is a philosopher and trolling philosopher, and has a philosophy and politics trolling Substack.
yeah, okay. It's going to be very spicy. Well, my first post is in the works. I'm just launching it, so you're ahead of the curve. It's utterly correct at substack.com. So that's like the animal, OTTERLY, CORRECT, because I'm always right. So I hope to see you there. Thanks for letting me do that.
So that was your payment for the work. But actually, no, technically, this event would have not worked without your help, Frank. So that's why we did an exception from our commercializing rule, because hosts and, well, the magic helpers, they have their distribution or whatever.
Yeah, and if I can just add one more thing. Yeah, sorry about the little technical difficulties. New gear. So next time we have a little checklist and we'll improve things and it'll be a lot smoother. So, gonna be better.
Then say goodbye.
Oh, well, bye everyone. More to come, more to come. So subscribe and stay looking out for it.